Use the product or quotient rule to find the derivative with sine and cosine. So in this video, we're going to be talking about how to use the product and quotient rule when we have sine and cosines as our functions. So our first example we're going to look at is y equals 5x cubed times sine of x. So since this is 5x cubed times sine of x, we're going to need to use the product rule, which means the first thing we're going to have to do is we're going to have to identify our first function and our second function. So I'm going to let 5x cubed be our first function, and I'm going to let sine of x be our second function. All right, then we just want to find the derivative. So dy over dx is going to be equal to, we're going to take the derivative of the first term, which is 15x squared, times the second term, which is sine of x, plus the original first term, 5x cubed, times the derivative of the second term, and the derivative of sine is cosine. And then all that's left is to simplify. And that's just to rewrite it as 15x squared times sine of x plus 5x cubed times cosine of x. And there is our derivative. Alright, next example, we want to find the derivative of y equals the quantity negative x cubed minus x squared minus 2x minus 2 times cosine of x. And again, since we do have multiplication here, we are going to have to use the product rule. So I'm going to go ahead and set the polynomial function, or the polynomial expression, to be my first function, and I'm going to set cosine to be our second function. Alright, now it's just time to apply the product rule then. So then y prime is going to be equal to the derivative of our first function, which is going to be negative 3x squared minus 2x minus 2. And remember, the derivative of a constant is always 0, so that's where that guy went. And then times our second, which is cosine of x, plus our original first, negative x cubed minus x squared minus 2x minus 2, times the derivative of the second, which is negative sine of x. Alright, then from here we just need to simplify, and there's not a whole lot we can simplify. I mean, if we wanted to, we could take the cosine and distribute it in, and then the sine and distribute it in, but that wouldn't really simplify our function. In this case, it would actually make it look a little bit more complicated. So we're not going to use the distributive property here. So really the only thing that we're going to simplify is we're going to take care of this negative sign in front of the sine function, and we're going to do that by moving it to the very front. So that means the plus sign is going to become a minus, and we're left with negative x cubed minus x squared minus 2x minus 2 times sine of x. And there we go. There is our derivative of y. Next up, we're being asked to differentiate the expression sine of x minus x times cosine of x. Alright, so we are being asked to take the derivative of this expression, so let's start out by doing that. So d dx of sine of x minus x cosine of x. And remember that d dx notation means that we need to take the derivative, and we haven't done it yet. Well, based on some of our rules, we know that if we are taking the derivative of subtraction, we can take the derivative of each individual piece. So we'll have d dx of sine of x minus d dx of x cosine of x. Well, the derivative of sine, we already know what the derivative of sine is, so not much there. We know the derivative of sine is cosine of x. And then minus. And then here, we have to be a little bit careful because we have x times cosine of x, which means we're going to have to use the product rule. So I'll choose x to be my first function, and I'll choose cosine of x to be the second function. And now I'm going to put the product rule in parentheses because we're going to have to remember that this negative sign, or this minus sign, needs to get distributed to every term, not just the first term. So again, that's why we're going to use the parentheses here. Now let's see, the derivative of x is going to be 1 times the second function, which is cosine of x, plus our first function, which is x, and then times the derivative of cosine, which is negative sine of x. Alright, then from here, we just have a bunch of simplifying to do, but nothing super difficult. So the cosine of x is going to stay on the outside. We're also going to keep the minus. And then let's see, 1 times cosine is just going to be cosine of x. Now, x times negative sine of x is going to be negative x sine of x. And now, since we have the inside simplified, we can now take the negative and distribute it to both terms. And that's going to leave us with cosine of x minus cosine of x plus x times sine of x. Well, now we can combine like terms because we have a cosine minus a cosine. And cosine minus cosine means those are going to cancel out, leaving us with our final answer, or our derivative, as being x times sine of x. Alright, so now let's take a look at how the trig functions are going to affect our quotient rule. So in this example, we're going to let h of x equal f of x over g of x, and we're told that f of x is going to be negative cosine, and g of x is going to be negative 3. So what is h prime of x? Well, since we are using the quotient rule here, we are eventually going to have to find the derivative of f of x and g of x, so why not go ahead and let's just do that right now. So the derivative of negative cosine, well, let's see, that negative can stay in the front, but the derivative of cosine is going to be negative sine of x. Well, negative times negative will be positive, so that means our derivative will be a positive sine of x. And then the derivative of g of x, or the derivative of negative 3x, will just be negative 3. Alright, so let's get to work on our quotient rule. So we are trying to find the derivative of x. So, we're trying to find the derivative of h. Sorry, wrong letter there. So h prime, we are going to have to use the quotient rule. Quotient rule says we take the derivative of the top, which is f, times the bottom, which is g, minus the top, which is f of x, times the bottom, which is g prime of x, and that's all going to be over the denominator, which is g of x squared. Alright, then from here we're just going to plug in all of our different functions. So let's see, f prime of x is going to be sine of x times g of x, which is negative 3x, minus f of x, which is negative cosine of x, times g prime, which is negative 3. And that's all going to be over g squared, or negative 3x squared. Alright, so we're going to do a little bit of simplification here. The first thing we're going to look at is that we have a negative cosine times a negative 3, so those both are going to become positive then, because negative times a negative is a positive. Now let's see, that's going to leave us with sine of x times negative 3x will be negative 3x sine of x, and then minus 3 cosine of x. And that's all going to be over, let's see, negative 3x squared is going to be positive 9x squared. Alright, well, we are not done yet because every term has something in common. So we can see here that all of our terms have a factor of 3 in them. So I can go ahead and I can factor 3 out of the numerator, which will leave us with negative x sine of x minus cosine of x. And then I can rewrite 9x squared as being 3 times 3x squared. And then the 3 in the numerator and the factor of 3 in the denominator will cancel out, leaving us with our final derivative of negative x times sine of x minus cosine of x all over 3x squared. Alright, next up we have another quotient rule question. We have x divided by 2 sine of x, and we're being asked to find the derivative. Alright, well we can see here that x is going to be on our top, and 2 sine of x is going to be our bottom. So let's get to work. So let's see, we're going to have y prime is equal to the derivative of the top. Well, the derivative of x is just 1, times the bottom, which is 2 sine of x, minus the top, which is x, times the derivative of the bottom. Well, remember, we can kind of ignore that coefficient based on our previous rule. And the derivative of sine is going to be cosine. And that's all going to be over the denominator 2 sine of x quantity squared. Alright, then from here we can do a little bit of simplification. Let's see, 1 times 2 sine of x is just going to be sine of x. And then x times 2 cosine of x is going to be negative 2x cosine of x all over, let's see, 2 sine of x squared. Well, 2 squared is 4, and sine squared is just that, sine squared. And there we go. We have our derivative of sine of x minus 2x times cosine of x all over 4 sine squared of x. Alright, and then finally we're being asked to differentiate the expression 1 over sine of x over 1, try again. Differentiate 1 plus sine of x over 1 minus sine of x. Alright, so since we are differentiating this, we need to start out d dx of 1 plus sine of x over 1 minus sine of x. And we can see that 1 plus sine of x is our top function, and 1 minus sine of x is our bottom function. So that means it's time to differentiate. So let's see, we're going to do the derivative of the top. So we're going to take the derivative of 1 plus sine of x. Well, the derivative of 1 is 0, and the derivative of sine is cosine. And we're going to multiply that by the denominator, or the bottom, minus. Then we're going to just rewrite the top, 1 plus sine of x. And then we're going to take the derivative of the bottom. And again, the derivative of the bottom, the derivative of 1 is 0. And we're going to be left with a negative. And then the derivative of sine is cosine of x. And that's all going to be over the bottom, 1 minus sine of x quantity squared. Alright, Wi-Fi, it's time for you to catch up. Do your job. Ugh, could you take any longer? Jeez. Alright, there we go. Thank you, Wi-Fi. Alright, so now there's just some simplification we need to do. We can distribute the cosine into both of those terms, and then we can distribute the negative cosine into both of those terms. And let's see where that leaves us. So that's going to give us, let's see, cosine times 1 is going to be cosine of x minus sine of x times cosine of x. And then minus, and since we have that minus operator here, I'm going to put the next expression inside parentheses, because again, we're going to have to distribute this minus sign into each of those terms. Alright, so now when we do some distribution, we're going to get negative cosine of x minus sine of x times cosine of x. And that's all over 1 minus sine of x quantity squared. Now we can take that minus sign and we can distribute it into our terms, which is going to leave us with cosine of x minus sine of x times cosine of x. And negative times negative will give us a positive cosine of x. And again, negative times negative will give us a positive sine of x times cosine of x. And that's all going to be over 1 minus sine of x squared. All right, well, you can see that we have a negative sine times cosine on the top and a positive sine times cosine on the top. So those are going to cancel out. We can also see that we have a cosine plus a cosine. Those are like terms, so we can add them together, giving us 2 cosine of x all over the quantity 1 minus sine of x squared as our derivative. All right, folks, and that is it. That is finding the derivative, that is using the product and quotient rule to find the derivative with sine and cosine.